This lesson we're going to talk about polynomial and rational inequalities. So we already know how to graph polynomial or rational equations. This time we're going to talk about inequalities, right? Inequalities. And example 1, let's look at the polynomial first. So the first step that I wanted to do is I wanted to set everything equals to 0. So standard form equals to 0. Descending order equals to 0. So then you will have 2x squared plus x minus 15 is greater than 0. And the second step is changing this to equation and find the boundary point. So you're going to do 2x squared plus x minus 15 equals to 0 and solve for x, and that's going to be your boundary point. Let's do that. So then when you factor this, we're going to have x plus 3 times 2x minus 5 equals to 0, where my boundary points will be negative 3 and 5 over 2. So let me graph that here. So on a number line, this is number line. Why number line instead of a rectangular coordinate system? Because you only have one variable x. You do not have y variable, right? So it will be number line. And you can mark your boundary points negative, smaller number on the left side, larger number on your right side. And then your step 3, you're going to test the area. When I say test area, because once you have a graph, now all you need to find out is that this area or this area, this area. So now with these 2 boundary points, you have 3 area. Out of this 3 area, which is the solutions that will satisfy this inequality. So now step 3 will be testing all this 3 area and see which area works. So then you're going to maybe test, I don't know which number. I like to use the smallest number as possible, so maybe negative 4. And I usually like to use 0 because that's easy numbers to play. And this is 5 over 2 is 2.5, right? So maybe 3. So I'm going to use 3 points to test it. So when I have negative 4, place back into my inequality, I have 2 times negative 4 squared plus negative 4, I end up getting that's positive 16 times 2 minus 4 will be 28, which is greater than 15. Here it's a greater than 15, right? And so that works out. What about if you try 0? If you try 0, let's see what we get. Plus 0, you get 0 times any number is 0, plus 0 is 0, which is not greater than 15. That's not true, right? That's not true. So negative 4 works. So this area worked, but the next area didn't. So probably the other area should work, but we wanted to make sure, so we wanted to check that number too. So that will be 3 squared plus 3. That gives you 18 plus 3 is 21, which is greater than 15. So that works out. So that area works. The next thing you wanted to do is making sure, go back to your inequality. This is greater. So you're going to use the parenthesis, not the bracket, right? So parenthesis, and interval notation will be parenthesis with negative 3 and parenthesis with 5 over 2 to the positive infinity and negative infinity. So that will be your solutions. Graph and interval notations. Okay, let's try another one. So this one, what was first step? Setting one side equals to 0 and the descending order, right? So you're going to have x cubed plus x squared minus 4x minus 4 is less than equals to 0. So once you made it in the descending form, now you're going to solve as equations to find the boundary point, right? Four terms. The way that you're going to factor four terms is using group factoring. So from the first two, you have common factor x squared, then you get x plus 1 remains. And from the last two, if I wanted to keep x plus 1 from it, I need to factor negative 4. Then I get x plus 1 there. Now from these two terms, common factor is x plus 1. You will have x squared minus 4 remains. This will give you your boundary points. This x is negative 1. This x squared equals to 4, where x should be plus minus 2 because you're using square root property, right? So with that information, let me just move a little bit so I can graph. You will have negative 2, negative 1, and positive 2. So because you have 3 boundary points, you have 4 different areas to test it, right? So maybe you could test negative 3. You could test 1.5. I don't like to use the decimal, but well, no choice there, right? And I can use 0. I can use 3, right? And usually, if this is the basic inequalities, if one area work, so if this area work, the next area should not work. It means the third area should be working and the other one will. So it should be rotating. That's why you have boundary points 4, long as this is the standard form. I'm going to show you the other types where it will not rotate. But right now, this is going to be something it will rotate. So the one that it's not going to rotate is if you have same of 2 solutions. Let's say you have 2 of negative 2. Then if this one worked, the other one should be working. If you have even number of the one solutions, right? But because you have one of each solution, if one area works, the other should not work, right? It should be rotating. So if I have that information, then depends on if this area work or not. I don't really need to try the decimal values, right? Because it's going to rotate. But just for sake of it, I wanted to prove you, I'm going to try all 4 area. So when I try, let me make sure, right? This negative 3, negative 1.5, 0, and 3 is the testing area I wanted to use, right? Negative 3, put it into the formula right here. Your given inequality, you're going to have negative 3 cubed is going to be negative 27 plus negative 3 squared is positive 9. And this should be smaller than 4 times negative 3 is negative 12 plus 4. And obviously carrying bigger negative number should be smaller. So this works out, right? It means this should not work out, and that works out, and that should not work out. But I'm going to prove it by plugging the points, right? So when I plug in negative 1.5 to third power, I get negative 3.375 plus negative 1.5 squared is positive 2.25. Let's see if that's smaller than negative 6 plus 4. That's not true, right? So we know that's not true already even before we plug in the number. What about 0? If it's a 0, that will be, the left side will be 0. Right side should be 0 plus 4. So 4 is greater than 0, so that works out. And we knew that will work out. And if we place 3, we get 27 plus 9. And 12 plus 4, right? And that's not true, right? 27 plus 9 is bigger, so that's not true. So then we know the area is going to be the first and third. What about inequality signs? You have less than equals to, you had equal sign. So you're going to use the bracket here, right? Bracket. No restrictions for the polynomial, so it'll be all bracket. And if you wanted to write this in interval notations, negative 2 with bracket, 2 all the way to negative infinity. And that's not it, bracket, negative 1, 2, bracket. So this is going to be your interval notations. This is going to be your graph. This is not bad, right? So instead of going over C, I'm going to do D. This time, first thing we wanted to do is always make a descending order, one side equals to 0, right? So I will have x to the 4th and plus x cubed minus 8x squared and minus 12x is greater than equals to 0. And if we wanted to set this equals to 0, to find the boundary points, you're going to have 4 terms factoring, so use the group factoring from the first 2 x cubed, you get x plus 1. In order to get x plus 1, you're going to factor 8x. So then you're going to get an x plus, well, 8 do not go into 12, so we cannot factor 8, right? And then this had to be x plus 1, and look like I will not be able to make that. So we know this is not the method we'll be able to use. Let me erase that. So then we're going to use different method, right? To solve, finding a boundary point. One method, well, maybe we can use the synthetic divisions. So in order to use the synthetic divisions, we can use just the number from each terms. So it'll be 1 from the 4th, and that's going to be 1 from the cube, negative 8 from the square, and negative 12 from the linear, right? The first. Dividing this by, you could try a different number, but I'm going to try negative 2 here. So if we try negative 1, we bring down this 1 straight down, so we have some numbers to multiply. Negative 2 times 1 is negative 2. That will give you addition of negative 1. Now negative 2 times negative 1 is positive 2. That gives you negative 6. negative 2 times negative 6, you get positive 12, which is going to be 0. So in order to get exact factor, synthetic division, the last number should be 0. This way you know this is factorable. So this is going to give you x cubed minus x squared minus 6x. It means you factor, from this you can factor x out. You get x squared minus x minus 6. So you keep reducing all the way to where you know you can factor. And this gives you x minus 3 and x plus 2. What about this number, right? That gives you, so when you factor that, it means you have factor x plus 2 out, right? So that should be carrying down. This 2 is same as having factor of x plus 2, right? That's what I have it here. It's all the way. So this one look like you have 2 of the same number. So for this, your x is going to be 0. This, your x is 3. For both, your x is going to be negative 2. So you have 2 of negative 2. If you have 2 of negative 2 on your inequality, remember the rotations is going to not work with that 2 numbers. So let me just mark this value first. This is negative 2. And then you're going to have 0 somewhere here. And then you have 3. So when we're trying this 4 different area, whatever the number we're trying, this 4 different area, if in this case, because you have 2 of negative 2, if this one worked, this is going to work also. If you have 1 of the solution, if this one worked, the next area should not work if you have 1 of 3 value. But because you have 2 of negative 2, it will continue. This, whatever this area will continue on the other area. And I can show you by testing the area, right? So if I wanted to test maybe negative 3, that's going to be negative 3, negative 1. Let's try 1 and 4. Negative 3, negative 1, 1 and 4. If it's negative 3, it will be 81 plus 36. And then 8 times negative 3 squared minus negative 3 cubed. That's 72 plus 27. And look like, yes, on the left side will be bigger. So for that reason, and having so this is going to be solutions. And then you have 2 of negative 2, so you know that had to be solutions. So this should work also. Then next area should not work. And then this area should work. Because you have 1 solution of 0, so it had to be changed. Right? And I'm going to show you by plugging the number. That is true, right? That's 1 plus 12 is greater than 8 plus 1. When you replace negative 1 in this, right? You're replacing negative 1 in the what we started. And it is 13 is greater than 9, right? And if we plug in 1, that will be 1 minus 12 and 8 minus 1, which is not true, right? This is negative number. This is positive 7, so that cannot be greater. If we place 4, this is going to be large number. 4 to the 4th exponent is 256. 12 times 4 will be negative 48 or minus 48, right? And then you have 4 times 16, so it will be 128, minus 4 cubed is 64. And look like this is going to be 208, this is going to be 208, this is going to be 64, so it is true, right? So it worked out, right? We know these two areas should work, and the last one, not the third one. And because we had greater than equals to, it should be bracket, bracket, and bracket. So interval notation of solution should be from 0 to negative infinity, and 3 to positive infinity. Graph and interval notation. Now we wanted to look at the rational inequality, right? Rational inequality, it works about the same, but the rational do have restrictions. So some of the boundary points, even though you have, equal sign right here, some of the boundary points cannot be bracket. Even any other boundary point will be the bracket included, right? But if that one of the boundary point is your restrictions, then you need to use the parentheses, not include that point. So that's a little different. So let's go over. So the first, step 1, you're going to let one side equals to 0. That's same as the other one, right? So if you wanted to let one side equals to 0, you're going to subtract 2. And then you wanted to simplify this, right? That's step number 2. Because you have a 2 term right now. So you wanted to simplify it to make it 1 fractions. So in order to do subtractions, you have to have same denominator. So you wanted to multiply denominator by x plus 3. It means you're going to multiply numerator by x plus 3. So then you will end up getting x plus 1 minus, you distribute negative 2 to x plus 3, you get negative 2x minus 6 on the numerator. Denominator, now you have same denominator, so it will be x plus 3. When you simplify that, you get negative x minus 5 on the numerator. Denominator will be x plus 3. So from this, you're going to find the boundary points. In order to find the boundary points, you're going to let numerator equals to 0, denominator equals to 0. But before I do that, that's my third step. I wanted to make sure from this shape, you will understand your restrictions will be x cannot be equals to negative 3, right? Okay, so that's important. So then step number 3. Oh, that was 2 right there, right? Step number 3, finding boundary points by letting numerator equals to 0, denominator equals to 0. So you end up getting positive 5, which is negative 5. That will be negative 3. So when we draw the number line, this is another number line because you only have one variable. Your boundary point is negative 5 and negative 3. So maybe you can test the points here, negative 6, negative 4, and maybe all the way back here, 0. So you will try, I will try the one with the easy number, which is 0, negative 4, negative 6. And when we try 0, it will be 0 plus 1 over 0 plus 3. That's 1/3. Is that greater than equals to 2? No, not really. That's smaller. So this area didn't work. Which area? This area, right? This area didn't work. And since I have all one of boundary points, if this area didn't work, this should be working and this should not, right? So for that reason, I know only middle works. If you want to, you can try that area to make sure it works. That's -3 over -1, that's 3. 3 is greater than 2, so that works. And so if you would replace -6, that will not work. But I'm not going to go that far because I already proved you from the other example. That's how it will work, right? And then you have equal sign. So because you had an equal sign, it should be greater than equals to, right? So it should be bracket. But don't forget that your restrictions, this -3 cannot be included. If so, even the problem says bracket, -5 is bracket, -3 should be parenthesis. So interval notation, let me write it on the top, bracket and parenthesis, number in between. So this is solution right there. Graph with interval notations. Usually inequality, that's what they ask. Should we try one more? B. So what do we do first? That one side equals to 0. And then simplify, make it 1 fractions, right? So that will give you, let's see what to multiply. It will be -3 over 1. So you're multiplying x plus 2 on the numerator and x plus 2 on the numerator. Denominator and numerator. Or denominator. Yeah, that's what I say, right? Then you should have 4x plus 5, distributing -3 to x, -3x, -3 times 2, -6 all over x plus 2. That will give you positive x minus 1 over x plus 2. So from this, I will notice my boundary point is going to be positive 1 and -2, but your restriction is -2 also. So you know that -2 should be used parenthesis, not bracket, right? So let's do -2 on the left side, positive 1. And I'm going to, because I already know one of boundary points, each boundary points. So whichever area it works, the other will not work, right? And I like to use the easy value, which is going to be 0. And 0 should be somewhere right here, right? So when I plug in 0 for my inequality, I wanted to check if it works. So that will be 0 plus 2. And this gives you 5 over 2. Is that greater than equals to 3? No, that's smaller. That's 2.5, right? So that area should not work. The 0 should not work. It means the other 2 should work because your solution should be rotated, right? So this 2 work, and we know -2 is the restriction, so use the parenthesis, and this is going to be bracket. And if you wanted to draw your interval inequality solutions, that will be your solutions, notations, and the graph. Last one. This time, it's the same. The step itself will be the same, but you have different denominators. Your denominator become more than one value, more than one factor, right? You're going to subtract, and then you wanted to subtract, so finding a same denominator, it will be x minus 2 times x plus 3. So then this 1 times x plus 3, and negative 1 times x minus 2 will be negative x plus 2. Don't forget I multiply this by x plus 3, multiply this negative 1 by x minus 2. Then I will end up getting, there will be no more x. So it will be 3 plus 2 is 5. Because you do not have any x variable on the numerator, I will not get boundary point from the numerator. But this will give you x equals to 2, and this will give you x equals to negative 3. And as the boundary points, but also at the same time, that's your restrictions, right? So even though this is greater than equals to inequality, both value, we have to use the parentheses because we cannot, it will start it from there, but it will not include that 2 points. So on the number line, you have negative 3 there, 2 there. Again, let's try maybe easy number 0, right? Your 0 should be somewhere right here, 0. So when you try 0 for your inequality, you end up getting 1 over negative 2 and 1 over 3. And this is not true, right? Why? Negative is not greater than positive, right? That's not true. So since the middle area do not work, it means both sides should be working. And we said that's going to be parenthesis, right? So your solution is negative 3 greater than negative 3, less than negative 3 to negative infinity, and greater than positive 2 to positive infinity. There's your solutions with the graph.